Okay, good morning. We're going to be learning about Arrhenius acids today. Basically acids. You're going to have three questions on the homework. I think Austin's already done them. So let's get right into it. Now, last time we learned about electrolytes. And electrolytes are essentially things that are going to have charged particles in solution, basically in water. So if I put a substance in water and it can carry an electric charge, like the video I showed, which will light the light, then it's an electrolyte. If it completely breaks down, like in an ionic solid, it is a strong electrolyte. It will allow electrons to flow very well. If it's a weak one, like acetic acid, then it does not, it's a weak acid or a weak base. They make weak electrolytes. In terms of what electrolytes do in your body, some of you watched the video and did the questions on that. Essentially they're salts, they're calling them salts, and they are going to help your body by maintaining good nerve impulses, allow electrons to flow that way. Okay? Today we're learning about what an Arrhenius acid is and identify some properties of acids. Okay, the Arrhenius theory basically says that an acid produces H plus ions. H plus ions. Okay? And these are called hydrogen ions. Some examples of Arrhenius acids are HNO3, that's nitric acid, HI, HBr, HCl in your stomach. Another one is H2SO4, that's sulfuric acid. Okay, so hydrogen ions are always hydrated or have water attached to them. In other words, when this acid, for example, is added to water, the hydrogen comes off automatically and it combines with water automatically. And then this, we have to know, is called the hydronium ion. Hydronium. Now if you have a strong acid, it will completely ionize in water. So some examples are nitric acid, like that one. That's nitric acid. Hydrochloric acid. And sulfuric acid. IC. Sulfur and then IC at the end. If it's a weak acid, it will not completely ionize. In other words, not all of the hydrogens will come off of the weak acid like in this one here, okay? This is ethanoic acid, or also known as acetic acid. This is the main ingredient in vinegar. So it's a weak acid, as I showed you the other day. It's a weak acid because not all of the acetic acid molecules will lose that hydrogen, okay? This is another weak acid called formic acid. And as you can tell here, these are both carbon-based, okay? Second thing here is properties. Aqueous solutions, you might remember that those are in water, conduct electricity. So acids in water will conduct electricity. If it's a strong acid, it does it well. If it's a weak acid, it doesn't do it very well. Acids will react with certain metals to liberate, that means to release or set free. Hydrogen gas. And that's in table J, but we probably won't focus on that too much. So active metals, sodium, magnesium, calcium, what's another one up there? Potassium. But at the same time, there are inactive metals like gold, silver, copper is another one, Cu. So if I put these three in acid, it doesn't really liberate, it doesn't release the hydrogen gas like a zinc or a magnesium would. Okay? So if I mix a metal with an acid, if it's more active than the hydrogen, it will release hydrogen gas. Okay? Then I would just have to balance this. That's a 2. All right. So what else do acids do? So again, they conduct electricity. They'll react with certain metals to release hydrogen gas. They do cause color changes in acid-base indicators. And I've got a couple here listed. Methyl orange is yellow in an acid. Litmus is red in an acid. And phenolphthalein stays clear in an acid. Another thing that acids are known for is to neutralize bases. Neutralize means to bring the pH back down to 0. So, HCl, that's hydrochloric acid, combined with sodium hydroxide, this is going to, they're going to switch essentially. Sodium is going to kick the hydrogen out, and the hydrogen is going to combine with the OH. So we get sodium chloride, which is salt, and HOH is the same thing as water. You may or may not remember that water has a pH of 7, which is neutral. Okay? So this is called a neutralization reaction. When we have an acid and a base, it's going to make a salt and water each time. All right, another factor, they are sour to taste. That's why if you taste vinegar, it's sour. Lemons or limes, that's citric acid, that's sour. Sour Patch Kids, I think they put malic acid on that. Okay? Just said it, citric acid. Vinegar, acetic acid. And another thing is, acids produce heat when they are diluted. And for safety reasons, you always add acid to water. And you always do that while stirring. Because if it splashes, if you add the acid to the water will surround the acid. If you add the water to the acid could splash up and then cause some problems on your body or your skin. Okay? So that's all we're going to do today. Tomorrow, or for homework tonight, I would like you to continue on this sheet, just the rest of the front. Up to number 5, I should say. Up to number 6, including 5. All right? Then I'll see you tomorrow. Bye.